Hi everyone, I'm Angelline Revereza. Today I discuss about the rule number. First, what is a rule number? A rule number is a value that represents a quantity along a continuous line, evolved over time by expanding the nation of that remained the whole number. At first, number meant something you could count, like how many sheep a farmer owns. These are called the natural number or sometimes counting number. The use of three dots of the list is a common. Next is the whole number. Whole number, a natural number with a zero, like 1, 2, 3, 4, and 5. What is zero? It is a number. How can the number of nothing be a number? Is zero nothing or is a something? Well, before the start to sounds like zero, come on, let's look at how you use a numeral zero. Arab and Indian scholars were the first to use zero to develop the place value number system that we use today. Next is the integers. Integers is a natural number like 1, 2, 3, 4, and 5. The next we can make is and include the idea of fractions. Fractions are numbers such for thirds. While it is unlikely that a farmer owns a fractions number of sheep, many other things in real life are measured in a fractions, like a half cup of sugar. If we add the fractions to set the integers, we get the set of rational numbers. Next is the rational numbers. Rational numbers are those numbers that can be expressed in a form A divided B, where A and B are integers, but B cannot be zero. Rational numbers include what we usually call fractions, that the word rational contains the word ratio, which should remind you of fractions. It might seem that the rational number would cover any possible number. After all, if I measure a length with a ruler, it is going to come out to some fraction, maybe 2 and 3/4 inches. Suppose I then measured it to very more precision. Next is the irrational numbers. Are those numbers that cannot be expressed as A sub B and decimal form. They are the non-terminating and the non-repeating decimals. I will get something like 2 and 5 by 8 inches, maybe 2 and 23 by 32 inches. It seems like, however, I think it is going to be some fractions. However, this is always the case. First, you have just drawn a length that cannot be measured by the rational numbers. According to the Pythagorean theorem, the length of the diagonal is the square root of 2. That is a number which, when multiplied by itself, imagine a line segment exactly the 1 unit long, like this. Second, draw another line 1 unit long perpendicular to the first one. Third, draw the diagonal connecting to the two lines. But my calculator only one step or 11 decimal places because it can hold no more. These numbers actually goes on forever past the decimal points without the pattern ever terminating or repeating. This is because if the pattern overstopped or repeated, you could write the number as a fraction. It may be proving that the square root of 2 never be written as square root of 2 is equal to 1, 4, 1, 4, 2, 1, 3, and so on. You have just drawn a length that cannot be measured any rational number according to the Pythagorean theorem. The length of the diagonal, you have just drawn a length that cannot be measured by the rational numbers. According to the Pythagorean theorem, the length of the diagonal is the square root of 2. That is a number which, when multiplied by itself, gives 2. According to the calculator, the square root of 2 is equal to 1, 4, 1, 4, 2, 1, 3, and so on and so forth. For any choice of integers for the a and b, the proof of this was considered quite shocking when it is first demonstrated by the followers of Pythagoras 26 centuries ago. That's all. I hope you learned a lot about the whole number. Thank you for watching. Bye-bye!
Lately, I've been losing sleep, dreaming about the things that we could be. But baby, I've been praying hard. Said no more counting dollars, we'll be counting stars. Yeah, we'll be counting stars.